Example 6. The angle of elevation from the top of a building 45 feet high to the top of a nearby antenna tower is 15 degrees and 20 minutes. From the base of the building, the angle of elevation of the tower is 29 degrees and 30 minutes. Find the height of the tower to the nearest tenth. Luckily, we have a picture of what is going on here. So if you look at where my cursor is, this is the building, and then over here, this is the antenna tower. Okay, so our goal is to find the height of this antenna tower. So that is going to be this yellow length right here. Okay, so let's look at what we do know. We know the height of this building on the left. It is 45 feet high, so this length right here in red is 45. We also know two angles. First of all, we know the angle of elevation from the base of the building to the top of the antenna tower. That's 29 degrees and 30 minutes. That's this blue angle. And then we also know this angle right here that measures 15 degrees and 20 minutes. It is the angle of elevation from the top of the building to the top of the antenna tower. Okay, now notice both of these angles are given in degrees and minutes. Let's begin before we do anything. Let's convert these both to decimal degrees, okay, because that will be easier to work with. Okay, so let's start with the 15 degree and 20 minute angle. So remember to convert degrees, minutes, and seconds over to decimal degrees. You need to say, okay, well, we have 15 whole degrees, and then you need to take the number of minutes and divide by 60 because there are 60 minutes in 1 degree. Okay, we don't have seconds here, so we don't have to worry about that. Okay, so if we go to our calculator, this is going to be 15 plus 20 over 60. So we get this repeating decimal. So we'd have to carry all the digits for accuracy. So I am just going to convert this over to a fraction. Okay, so this is going to be 46 over 3, that many degrees. Okay, so that's what we need to use for the degree measure of this angle. Okay, it's a little strange, but that's what you have to do to carry all the digits. As far as the blue angle, 29 degrees and 30 minutes. Okay, this is going to be 29 whole degrees plus 30 out of 60. Okay, so 30 over 60 is 1/2. Okay, so this is going to be basically 29.5 degrees. Okay, so that one's not as bad. We can just use the decimal approximation here because it's exactly 29.5. Okay, so we've converted these guys over to decimal degrees so they're easier to use. So now let's talk about how we're going to attack this problem. Okay, so when I look at this picture, okay, I see several triangles that are formed. I see a rectangle. Okay, so let's talk about the rectangle first. Okay, so I see this rectangle that has been made. Okay, so we know that this side of the rectangle is 45 feet. So that means this side that I'm coloring in red also has to be 45 feet. Okay, so we know a portion of the antenna tower. We know this red portion's height. So what that means is our goal is going to be to come up with this green part. Okay, we need to know how tall this little green part is. Okay, I am going to call that something, I don't know, let me call it Y. Okay, we need to figure out what that green value is, and then once we know it, we can add it to 45, and that will give us the total height of the antenna tower. Okay, so let's think about what we can do here. Okay, so we've got to focus on this green line segment. Okay, so we have a couple of right triangles involved. So let me shade them in here. Here's a right triangle. Okay, when I look at this picture, I see this right triangle. Okay, and then here is the right angle right here. Okay, the angle formed by the base of the antenna tower in the ground. Okay, so if I'm trying to find this green measurement, this right triangle really isn't any help. okay? Because if we go opposite this given angle, that's this entire side, the green plus the red. Okay, so we're not going to be able to set up a trig ratio, a right triangle ratio, that's going to give us just the green portion. Okay, so that's not going to work. Okay, so let's look at another right triangle. Okay, there's a smaller right triangle, this guy. Okay, so let me shade this in really quick. All right, so if we look at this right triangle, and for this one, the right angle is right here. Okay, we're thinking right triangle trigonometry. We know this angle right here, okay? And if we go across from it, this is super, that's the unknown, okay? That's the green portion that we're looking at. But the problem is we're not going to be able to set up a right triangle ratio because we don't know anything else about this triangle. We don't know any of the sides. Okay, we know all three angles. Like we could subtract out from 180 and get the remaining angle, but that does us no good if we don't have any of the side lengths. Okay, so that's not going to work. Okay, this actually could be helpful in the end if we knew one of the sides of this right triangle. Okay, because all I would have to do, okay, let's think about this going forward. If we knew one of the sides, okay, then we could create the right triangle ratio. Okay, so that is going to be our goal here. Okay, we need to try to figure out something else about this right triangle. Okay, so let's back away from this. We'll come back to it. Okay, so if you look closely, there's actually another triangle in this picture. Okay, I'm going to color it purple. Okay, it is not a right triangle, it is oblique. Okay, but here it is. Okay, if you notice this side, and I'm going to color it black, okay, this side right here, it is shared by the purple triangle and the one that I had highlighted green. Okay, if we can figure out this side, okay, it is shared by this triangle and by the green triangle, that will give us a side in the green right triangle, and then we'll be able to set up a right triangle ratio. Okay, so what I'm going to do going forward, okay, is I'm going to use either the law of sines or the law of cosines to figure out this black side of this oblique triangle. Okay, and then I will return to the green triangle. All right, so let's do some labeling here. I need to put like an A, B, or C on here. Again, we're concentrating right now on the purple right triangle. Okay, I'm just going to call this vertex A, this is vertex B, this is vertex C. So I've got the 3 points of this purple triangle, okay? And we are going to be interested in side length A, okay? Because this is going to be the side across from angle A. This is angle A, okay? So let's talk about what we know about this purple triangle. Obviously, we know the red side, that's 45 feet. We actually know the measure of angle B, okay? This is angle B. Okay, if you notice, angle B is made up of a right angle, this right angle, okay, and this little smidgen, the 15 degrees and 20 minutes, okay? If you take the 15 degrees and 20 minutes and you add 90 degrees to it, that's going to give you angle B, okay? So I'm going to write that out here, okay? So angle B is going to be 15 degrees and 20 minutes, which we said was 46/3, that many degrees. And then we need to add a 90-degree angle to it, okay? And that's going to give us angle B in degrees, okay? So we need to take this value and add 90 degrees, okay? And you can convert it to a fraction. It is, because it's probably a messy decimal, this is going to be 316/3, that many degrees. Okay, so we know the angle B, okay? We also know angle A, okay? Why do we know angle A? Well, the ground and the building form a right angle, okay? So the blue angle is 29.5 degrees, and we know that if we add this purple part here, okay, this little what I'm writing on right now, if we add this part to the 29.5 degrees, that's going to be a 90-degree angle, okay? So to get angle A, Okay, and again, when I'm talking angle A, let me color this in a different color. Angle A is this angle in orange. Okay, so angle A is going to be a full 90 degrees minus 29.5 degrees. Okay, so 90 minus 29.5. Here we go. This is going to be a 60.5 degree angle. Okay, so when we are looking at this particular triangle, we now know the case. I know an angle, a side, and an angle. Okay, so this is an angle, side, angle case. And for angle, side, angle, you use the law of sines. Okay, we are going to use the law of sines to get side length A. So let's figure out, what do we need to use for the law of sines? Do we need to use the A and B information, the A and C information, or the B and C information? Okay, well, we're looking for A, side length A, so we're hoping to use sine of A over A. Okay, and we do know angle A. Okay, so it looks like we can do that. So I'm going to go ahead and jot that down. Okay, so we're going to have the sine of A over A. Okay, so let's see, what else should we use? Should this other side be sine B over B, or should it be sine C over C? Well, the thing is, if I look at angle B, I know what angle B is. However, I don't know side length B. Okay, if I go across from angle B, this is side length B. I do not know it. Okay, angle C, we don't know it either, but we can figure it out because we know angles B and A. We can figure that out, and we also know side length C. Okay, so that's this red part. Okay, so the best choice here is going to be sine C over C. We need to take a minute and figure out what angle C is. Okay, so angle C, all the angles in the triangle add up to 180 degrees. So we need to subtract out angle B as well as angle A. Okay, so angle B is this 316 over 3, that many degrees. Angle A is 60.5 degrees. Okay, and that will give us the decimal degree measure for angle C. Okay, so let's do it. So we're going to do 180 minus 316 over 3 minus 60.5. And we need all the digits. Okay, so convert to a fraction. Angle C is 85 over 6 degrees. Okay, so you would do the 85 over 6. Okay, whatever that number is, it's that many degrees. Okay, so now we can plug all of this into the law of sines. Okay, so we're going to get that the sine of A is 60.5 degrees over side length A, that's what we're looking for. That has to equal the sine of angle C, so 85 over 6, that many degrees, over side length C, which is 45. That's that red side. Okay, we have one unknown. We're going to be able to solve for side length A. Okay, we have two fractions equal to each other, so we need to cross multiply. Okay, this is going to tell us that A times the sine of 85 over 6 needs to be equal to 45 times the sine of 60.5 degrees. Okay, the sine of 85 over 6, that many degrees, that's just going to be a number, so we need to divide it off. So to compute side length A, this is going to be 45 times the sine of 60.5 degrees over the sine of 85 over 6, that many degrees. Okay, you need your degree symbol, otherwise the angle is understood to be in radians. Okay, let's go pop this into the calculator. Make sure you're in degree mode. So this is going to be 45 times the sine of 60.5 divided by the sine of 85 over 6. Okay, because your calculator is in degree mode, this is understood to be a degree measure. Okay, so here is the length of side A. Okay, so I'm going to go write it down. I'm going to use all the digits here. Okay, so A is going to be 160.0288927. Okay, that is a length or a distance. Okay, everything in this problem is in terms of distance. This is going to be measured in feet. Okay, so that is this side length. Okay, this is the 160.02 dot dot dot. So now that we know this side, okay, this side is shared by the purple triangle and the one that I had originally colored green. Okay, let me see if I can get that to come back up here without erasing too much. Okay, so now we're going back to this green right triangle. Okay, because remember the end goal here, what are we actually trying to find? We're trying to find this green line segment on the part of the antenna tower. Okay, so if we're going back to this green right triangle, now we know angle B. Okay, angle B is, I'm sorry, I misspoke. Angle B, remember, is this entire angle. Let me see, let me get a different color. Angle B, I was calling this entire angle right here. We know this green angle right here. Okay, we know this angle. That's the 15 degrees in 20 minutes. Okay, and now we know this side. Okay, and then this y distance is what we're trying to find. So we're going to be able to set up a right triangle ratio because we know enough. If we go across from this angle, that's our unknown. This is the opposite side. And then if we go across from the right angle, side A is the hypotenuse. So we know the opposite, well, we're looking for the opposite and we know the hypotenuse for this particular angle. So our right triangle ratio here is going to be that the sine of 15 degrees in 20 minutes is equal to the opposite side, which is y, that's what I'm calling y, over the hypotenuse, which is this 160.0288927. Need all the digits. Okay, so this is what I need to solve. Okay, I wrote 15 degrees in 20 minutes because I didn't have the conversion in my eyesight, so let me go back and put that in. So this is going to be the sine of 46 over 3 many degrees. I'm right here. Okay, going back to that work. Okay, so the sine of 46 over 3, that many degrees, has to equal y over this number. All right, and so all we need to do now is solve for y. Okay, to do that, since this is a fraction, I'm going to multiply both sides by this decimal number. Okay, and let's see what we get once we do this. Okay, on the right side, these decimal numbers, you have one in the bottom and one in the top, they will cancel. So to get the y value, that green distance, we just need to take that 160 dot blah 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 decimal and multiply by the sine of 46 over 3. Okay, so let's do it. So we're going to take this decimal, okay, and we're going to multiply it by the sine of 46 over 3. Okay, that's going to give us the green measurement. Okay, so 42, okay, this is going to tell us that y is 42.317.106.13. Okay, that's this green distance. Okay, so now that we know the green distance, we can just add it to the red distance. Okay, so to get the height of the antenna, so height of tower, okay, notice the directions say to round to the nearest tenth. Okay, the red piece is exactly 45, so let's go ahead and round the green piece. Okay, if we round to the nearest tenth here, here's the tenths place. There's a 1 that comes after it, so we can just round this to 42.3. Okay, and then add the 45 feet. Okay, so this is going to give us a grand total of, let's see, we've got 42.3 plus 45. Okay, this is going to be 87.3. Okay, and the height here is going to be measured in feet.